All right, here's a really good question about understanding about dissociation and looking at concentrations of ions in solution. So it says the calculated concentration of chloride ions when 100 mils of 0.231 molar sodium chloride is mixed with 250 mils of 0.150 molar calcium chloride. Okay, so let's just understand what's going on here. So I have a container, and in here I have sodium chloride. And I know that when sodium chloride dissociates, it gets sodium ions and chloride ions. And of course you'd have water in there too, but these are the guys we're looking at. Now they tell me that the volume is 0.100 liters, and they tell me that the concentration is 0.231 moles per liter, or molar. Okay, now just using my formulas here, I have C equals N over V. If I know C and V, I can figure out how many moles of chloride ions are in there, are in this container. Okay, same game over here. This time I have calcium chloride, and so I have calcium ions and chloride ions in here. And I know a volume. It's 0.250 liters, and the concentration 0.150 moles per liter. So same thing, based on that I can figure out how many moles of any one of those species that are in there. And then what I'll do is I'll dump them into one big container. I'll have a certain number of moles, a total of moles, and I'll have a total volume, and I'll use those two things to figure out my end concentration. That's sort of where I'm going. Let's first look at the sodium chloride. So sodium chloride is solid. If you dump it in water, it dissociates into sodium ions and chloride ions. And notice that they're 1 to 1. So if I have one of these, it gives me one of those and one of those. Okay, so let's look at, they tell me they have concentration and volume here. Let's use that formula to figure out the number of moles. So C is equal to N over V. If I'm solving for N, I'll multiply both sides by V. So I'm going to get C times V. Again, if you have problems rearranging formula, let me know. Concentration 0.231 moles per liter times the volume 0.100 liters. Okay, so together that will be 0.0231 moles, because the liters cancel, and that is of sodium chloride. Now just going back to my mole ratio, so it says if I have 1 mole of this, it produces 1 mole of that and 1 mole of that. What we're looking for is they're saying what is the concentration of chloride ions. So they want to zoom in on the chloride ions. Well, if I have 0.0231 moles of this, I'm going to get 0.0231 moles of this and 0.0231 moles of chloride ions. So maybe I'm just going to put an arrow here and say that this means from that 1 to 1 ratio that I'm going to have 0.0231 moles of chloride ions. But that's only in this first container, right? So now I've got to figure out how many moles I have in the second container. Let's change colors. I'll go to there. Okay, so let's look at our calcium chloride then. So calcium chloride is a solid. When you dissolve it in water, it dissociates to form calcium ions and chloride ions. Now to balance it, of course I need a 2 here, and that's going to have implications for us here in a minute. Okay, so if I have one of these, produces one of those, and two chloride ions. So let's use our formula to figure out how many moles we have. So C equals N over V. So N would be equal to C times V. The concentration of calcium chloride is 0.150 moles per liter times the volume 0.250 liters. Liters cancel. Notice I just converted everything to from milliliters to liters. It's best to do that. Uh-oh, my calculator is dead. It's okay, I have a phone. Need to charge that calculator. Okay, so point times 0.25. There, 0.0375. 0.0375 moles of, they said that was the concentration of calcium chloride. Calcium chloride. So this concentration will be 0.0375. If it's 1 to 1, then this will be 0.0375. But this one is going to be double that. So I got to double that. Take that number times 2. 0.075. 0.075 moles. Okay, so this was my moles of calcium chloride, and from that, in my dissociation equation there, I know I have 0.075 moles of just the chloride ions. Okay, so they say what is the concentration of the chloride ions when you dump them in together. So now what I'll have to do is take a total. So here are the chloride ions from the second solution. Here's chloride ions from the first solution. I'll add those together. So moles from sodium, it's not moles of sodium chloride. Let's say I'll just put a 1, and this is our solution 1. Plus the moles of 2, this is our solution 2, will be equal to, so 0.0231 plus 0.075 equals, calculator, 0.0231 plus 0.05, there we go, 0.0981 moles of chloride ions. So the question says, what is the concentration of chloride ions? So if I look at my volume, here I've got 100, and here I've got 250. So that's 0.350 liters. That's what these chloride ions will be into. So let's use our concentration formula. So the concentration of chloride ions will be equal to moles over volume. The total moles we just found, 0.0981 moles, divided by the total volume was 100 plus 250, so 350, so 0.350 liters. Okay, let's divide those, and then hope that that number's on the multiple choice. 0.0981 divide 0.350. 0.280-28571 moles per liter. Sig figs, let's just go back and look at that. 4, 3, 4, it looks like 3 is my weakest link. So I need to do 3 sig figs. 0.28, since this is less than 5, we'll leave this at 0. And you have to put that 0 in for sig figs. Moles per liter or molar. That's the answer I'm going with. Let's see if they have that as one of the answers. Oh, right there. They even have the sig figs right. Nice. Okay, hopefully that helps you with that question. Gives you an understanding of determining the concentration of ions in solution, and then if you put them together, figuring out the total concentration.